Everyone can see my screen well. So first of all, thank you so much for joining the DevSecCon 24. Just to give you a bit of history, I've been talking since 2016 of DevSecCon. It's been definitely a privilege and honor to share my knowledge and the research and the work I have been doing. Today, we will be focusing on very interesting talk, especially around Kubernetes security. And we will be focusing on a project called Kubernetes Goat. And we will be looking at how we learn about Kubernetes security using an interactive learning playground, right? A bit about me. If you're someone completely new towards working with me, I've been working in cloud and container security for a while. I've been recently doing my own corporate or like a consulting work. I've been fortunate to work with a bunch of open source projects like Kubernetes Code, Hacker Container, a bunch of other similar projects. I've been speaking and training my research at various conferences around the globe, like Black Hat, DEF CON, Usenix, and some of the other. And pretty much I've been actually learning and sharing my research. So that's why you see me never-ending learner. So if you're someone wanted to follow me or my work, you can follow me at Twitter at Madhu Akula or most of the social media. So with that, why really Kubernetes security matters, right? So I just wanted to take you through quick glimpse of like what is the real reason behind this, and then maybe most probably we'll look at how we can solve these problems, right? So one of the biggest thing is Kubernetes has been like tremendously popular and adopted extremely well across the industry, right? So one of the biggest problem is most of the security teams does not have knowledge about how these terminology. Sometimes it may be how they operate, or maybe the operational working knowledge, right? So this is one of the biggest reason, right? So we need to understand if something got hacked, like how do we fix them rather than just deleting like a pod or like a VM, like old school, right? So if you look at another picture, right, it's increasingly rapidly growing across the cloud native landscape. If you look at landscape.cncf.io, which is like a bunch of projects, not just Kubernetes, but a sister or like around projects which works or around Kubernetes is insanely growing. And most of the companies adopted them, right, because they have certain kind of use cases and work lifestyle, right? The biggest thing is technology gap and adoption and maturity, right? If you don't understand the technology, basically you can't secure it, right? So that's where a lot of security skills are like gaps missing, especially in the modern technology. Things like Kubernetes, maybe it's a recent cool talk by Ashish also, LLM, right? Maybe that would be the new Kubernetes or something like a fancy thing, right? So if you look at what really matters from the hackers or attackers or real world perspective, these are a bunch of the screenshots. I'm really apologies for the very small font. I'll share the slides, you can see. But if you look at them, there is a lot of real world hacks happen. Things from like a simple SSRF, like application vulnerability, to complete cluster takeover, or RBAC privileges or least privileged escalations, or things like even official Docker hubs getting hacked, or crypto miners everywhere, like things like maybe Monero or crypto checking, whatever the crypto miners, right? And new 0 days like container escapes and bunch of the things, or misconfigurations, right? So there are a ton of security vulnerabilities out there, which is basically impacting the real world aspects, which could be developer productivity, where they are trying to write the code and ship it to the production, or operational efficiency, where people basically maintaining these applications and making sure they are up and running like 24 by 7, right? So as a security team, we wanted to understand these technologies and the risks so that we can able to help them or provide a mitigations or best practices to secure them in a real world approaches, right? So that's where I wanted to give you a glimpse of different areas or layers of the Kubernetes security. Definitely, there is no single way or approach, to be honest with you. There are a ton of ways how you can approach or adopt these security models. So I just took about like simple layers, like things like application security. Even though you build a super rock solid like secure systems, maybe like an infrastructure or Kubernetes, but if there is a simple vulnerability in application, it's completely a huge bypass in a lot of layers, right? So that's why I kind of defined or divided into like a different layers, like image security, container, infrastructure, runtime, and bunch of other areas. So I just wanted to quickly delve into one of each very high level. By the way, if you are someone who wanted to deep dive, definitely I think there are a ton of resources and work, especially from DevSecOn, as well as bunch of the open source work as also available. So please refer to them. So application security is something quite crucial because most of the code at the end run by the engineering or things which is resources running the Kubernetes are application code. If you don't follow the best practices like SDLC software security, or maybe code reviews, or performing pen testing, vulnerability assessment, or even some things like maybe simple scanning, right? Or maybe completely training developers, right? Understanding the best practices. There could be a number of ways. So, but application security is quite serious because if something is going to have a simple application security flaw, basically all your commercial vendors and $1 million firewalls getting bypassed, by the way, right? So once we did all the best practices and we have best in class application security team to fix them, right? Our products. Then we come to the image security, right? Once you completed written code and everything, you kind of package this application into a container image. So now we wanted to focus on the container image security, where we basically think about, okay, do we have any known vulnerabilities? Did we scan for any security concerns or dependencies or secrets or bunch of things? Or also because like a lot of these recent issues coming like images or container registries getting hacked or putting backdoors, right? So maybe do you wanted to implement like signing and verification so that you have built the trust and verification throughout the life cycle of supply chain, right? So these kind of things are quite important, and that's where, without saying came like supply chain security. I think you have seen recent how impactful supply chain security concerns, things like Log4j or other issues. But in Kubernetes world, it's quite complex compared to the traditional world, right? Where if you look at the simple container, it can be built or created or packaged in application code somewhere in developer's laptop in maybe somewhere in New York, right? But the application is getting deployed somewhere in the Europe, right? So it's completely, if you look at like a real world, like a completely non-technical, like a supply chain and the real world supply chain of this technical side, it's not much difference, but there are how security gaps you take is quite different, right? From writing developer application code to deploying into production, there are a lot of pages like choosing the specific library, choosing the certain dependency. Do we have any validation and sign this code once you package into a container, right? So there are quite a lot of heavy momentum and efforts has been done in CNCF and in general supply chain world. So quite a lot of people follow something called SALSA framework, which is basically 4 layers or levels of the framework, how you can adopt and apply the supply chain security best practices. So maybe this would be a good start if you are someone trying to adopt this, right? Or even I think I saw CNCF has done quite fabulous work on supply chain security white paper as well, right? So, okay, we have done everything fixes. Now it's time to deploy and run in the infrastructure, right? So now it start thinking about, oh, how does the Kubernetes cluster is running? Do we have any secure defaults? Do we have any firewalls, or maybe network is open, or do we have any RBAC rules, right? So there is a lot of things comes into the picture, especially due to the nature of Kubernetes is mostly distributed systems. So things are like more different from the traditional firewalls. Okay, maybe you created a VLAN and you put the host there, it's not going to be the similar way, right? So thinking about these is quite important. And now finally, how you run this container. Now you wanted to think about container security perspective. So do we have any proper resource limits set? Did we have any security context enabled? Did we give all the specific capabilities only required, not giving you completely all the capabilities we have in the world, right? So I'm definitely looking at almost 30,000 foot view. So if you wanted to go deep dive, definitely I'll provide some resources, but think about like these as a different layers you wanted to look at in the Kubernetes world, right? And now cluster security, right? How do you make sure like cluster is running safely and securely? Some of the people might be running in the managed providers like AWS EKS or Google GKE or something like that. Maybe how much security they do take care of. It's like again coming to shared responsibility or shared sense of security, right? So do you take care of API server security? If someone compromise them, how do you get those logs? How do you make sure they are up and running, right? So do you enable any network security policy, or how do you give access to this API server, right? So these kind of things can keep pop up. And if you look at all these layers, at least like one of them just broke, basically most of the security issues or concerns get arised, right? So network security getting quite a lot of popularity, especially in Kubernetes world, given the flat networking scheme. If someone is trying to have much more capabilities or leverage, so how you can leverage the network security capabilities also quite important. Things like implementing network security policies, or helping to make sure encrypt rest in transit or rest in like motion. Some things like most people I see in the real world is maybe they are just within the cluster. It's okay to not encrypt maybe pod to pod or service to service. What if one of the pod or service internally is malicious or backdoor? Maybe they can listen to all the traffic or like maybe this data or systems, right? It depends on how they schedule, how they communicate, right? So things like these are extremely overseen, and most people miss out, and these will bring a lot of security concerns and risks in real world, and especially regulated industries like fintech and health industries, right? So finally, I think the runtime security, I think this is quite getting extremely useful because things like near real-time capabilities, especially what's going really happening in the Kubernetes, because containers going to spin up and going to shut down in a matter of seconds. As an attacker or like maybe defender, you wanted to quickly able to understand and detect those alerts or maybe attacks and able to respond them in near real-time fashion, right? So things like this is quite advanced, and at least some of the companies I work as consultant seen quite a lot of maturity gap in the runtime security or how they detect security attacks in Kubernetes world, or maybe most of the infrastructure in modern like maybe it's just not Kubernetes, right? Any container orchestration world, because of the nature of Kubernetes or containers is quite different from traditional world. So detection capabilities is not matured in the real world or industry side, right? So that's where this whole talk comes into the picture actually. How can we learn and practice so that we can able to bridge these gaps in different layers, or maybe bring some security capabilities or understand them so that you don't want to make these mistakes and build a bad practice in your organizations, right? So that's where I wanted to introduce a project called Kubernetes Goat. I just asked a simple question to ChatGPT, right? What is just exactly Kubernetes Goat? So I definitely don't want to go through all this the example. So in a simple, Kubernetes Goat is basically deliberately vulnerable by design Kubernetes cluster, which is basically has intentionally known vulnerabilities, which is commonly happen in the real world, so that you can go back and practice them, so that you can secure your clusters, are able to understand real world attacks, are able to basically fix them using security tools or products. So yeah, it's basically both offensive and defensive, as well as people can use as a vendors as well, right? So big disclaimer again, as I mentioned, it's a deliberately intentionally vulnerable application. Please do not run this in your production clusters or any workloads, because it has ton of security misconfigurations and vulnerabilities. If someone basically has access, basically they can take over complete cluster, right? And also these vulnerabilities are showcased completely for education purpose. So please do not go back and just test because you have access to some cluster in the internet, right? Okay, now you said all the context. So how can I get started, right? Can I really use the Kubernetes Code? So Kubernetes Code is intended for a variety of audience. So think of this like a different spectrum of audience. So if you're someone completely coming from attacker or red team, maybe you can learn to find vulnerabilities or use Kubernetes Code to understand how I can hack the Kubernetes clusters, or maybe find real world vulnerabilities or misconfigurations, or maybe privilege escalations or container escapes, right? Whatnot. So if you're coming completely from different side, like defenders or blue teams or detection side, maybe you can learn all these attacks and see how you can able to detect these vulnerabilities or mitigate them, or like maybe write a fine-tuned rule or create some TTP actions, right? Mapping back to Metri or what kind of frameworks you have. And I think Kubernetes Code also comes bundled with a lot of defensive scenarios, things like Falco, eBPF, and a bunch of the other things, right? How you detect these vulnerabilities in real-time fashion. And I definitely don't want to go much deeper, and I don't want to leave this. Developers and DevOps has huge impact in this, the modern infrastructure. So helping them to understand how these simple misconfigurations could be fixable and how much impact it will bring in a real world, like maybe in the business or the production, right? So it will make an immense effort to fix or reduce a lot of security issues. So this has been proven, at least I work with a bunch of companies doing consulting, a lot of security issues fixed in the developers or DevOps stage in a large scale. It is very scalable to the organization also, how you can fix these issues in the real world, right? And I have seen with a lot of vendors as well leveraging Kubernetes Code, things like Microsoft Defenders and a bunch of other companies leverage Kubernetes Code to see really if their products, what they say is working or not, and can they able to detect these vulnerabilities, right? These are a bunch of the vulnerabilities currently we have in Kubernetes Code. Definitely, it's a quite active and quite slow project, but it's been quite stable and quite a longer project. We have ton of projects scenarios coming up, but this is something you can try out right now, right from your browser or like cluster, right? So you can quickly set up the Kubernetes code using any one of the formats, like using your own vanilla Kubernetes clusters to K3s or whatnot, right? So you can set it up as simple as like cloning this repository. Definitely check it out what it's going to install. It's going to set up a bunch of vulnerable applications and pods and deployments and cron jobs, whatnot, right? So once you're able to set it up, you should be able to see this up and running status of the Kubernetes code pods and everything. Then basically you should be able to see this home, which is Kubernetes Goat home, right? So it's basically quite designed towards pretty much anyone who wanted to learn Kubernetes security. It doesn't matter if their background is security or someone developer or DevOps or maybe even like someone who's looking into different aspects, right? So this has complete detailed guide. I quickly going to go through some of the scenarios and guide, but this is where you can refer madhuakula.com/Kubernetes code. It's extensively documented than any commercial product or vendor, even though it's open source. So we also try to map it back bunch of these scenarios with popular projects like Kubernetes Code to open source Kubernetes top 10 OWASP, right? So some of these scenarios, if you want to learn how you can practice them in a real world, right? Even though with mid-array mapping, like it in attack framework, slowly we're going to implement defend as well, which is like a defensive side. So you can try out a bunch of these scenarios in real world as well, right? So let me quickly showcase and how you can learn and further you explode so that you can go back and explore the Kubernetes Code project and basically fasten your learning, right? So if you head back to Kubernetes Code project, which is definitely a bit active, so you can refer the documentation and the setup here. Or if you're someone basically wanted a very guided thing, basically you can go to the Kubernetes Code documentation here. Yeah, it's quite a popular project. I also didn't see that many pulls outposts, 1.6 million. Cool. So basically, you can refer the all documentation here. So each and everything, as I said, mapped back to some of these frameworks. Let's click on one of the scenario, for example. So Docker in Docker. So each scenario is quite designed towards a learning experience as well as someone who is security learning as an attacker side or defender side or maybe even developers and DevOps, right? So if you look at simple scenario like container escape, like Docker and Docker exploitation, so you kind of have an overview and there is a guided like image basically trying to showcase and explain what exactly this attack, because there is a container socket mapped from the host system to container. So basically we leverage this to exploit and gain access to the host system. Maybe you can access from here host processors, host networks, and basically other containers, right? And pretty much. So it kind of explains how you can solve this scenario, and it explains how it relates to real world examples. And if you have someone already set up, you can click to this link. Basically, it will open up the application as they're getting started. So from there, how you can exploit and solve. If you have someone wanted to solve this as a challenge, you can stop it here and go ahead and solve. And it also have a bunch of goals. What is the outcome of solving the scenario? And it'll also have some hints if you stuck somewhere, basically. So yeah, this is quite handy if you are someone trying to learn and without seeing the solution. But if you're someone completely want to try out like by learning, and if you stuck, basically you can also refer through the solution and walk through. So each of the scenario has a detailed walkthrough on some of the references, right? So there are a ton of scenarios like container escape to the host system and Docker in Docker, as you see, ton of other attacks. So even if you are someone completely coming from maybe compliance or non-security or maybe sorry, a different world, so there is things like CS benchmarks where you can adopt like apply compliance checks for both Kubernetes and Docker, and how we can adopt them. And if you're someone trying to come from maybe most probably defensive side, maybe you also have some things like doing file code detection, like how you detect certain attacks in real time using things like sysdig falcom, or maybe even eBPF, like how you can detect some of these attacks, right? So I would definitely not going to go through a lot of all of them, given we have 30 minutes of the time. But as you've seen, there is a quite a lot of the things, and yeah, I will be going back to the session. So let me quickly go back. Yeah. So the adoption is definitely quite huge. Even things like bigger industry vendors like Microsoft Defenders use this to see if they really detect these vulnerabilities in a real world, right? So please try to give it a feedback of the project. So there is a ton of other things coming up, especially more scenarios and how we can work with a lot of OSs and vendor tools so that we can bridge the gap between the real world security vendors and security attacks happening in the real world, right? And a lot of push towards how developers can adopt and learn security, because that is something we have seen personally. I have seen it would be huge benefit if you wanted to scale security at a company where you wanted to build secure best practices or scalable security in the Kubernetes, right? So we wanted to build more scenarios. If you're someone wanted to contribute, please feel free to come back. And one thing I can definitely expect or at least ask from you is please do share the love with the community. Give it a try. Contribute if you have any ideas and suggestions, or just start in a GitHub, right? So with that, I wanted to thank you so much for giving this opportunity, for sharing the project with the audience and wonderful community. And I would be really happy if you have any questions to take, or if you want to tweet to me later as well. You can follow me at Madhu Akula. But yeah, just waiting for the questions.